Hello everyone, welcome to the course Data Structures. This is N. Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Let us see the overview of the today's session. In today's session, we will be discussing about double linked list insertion operations. In the previous session, we have discussed already what is a double linked list and how we are going to perform the creation and display based on double linked list. And coming to the insertion part, here we are going to discuss about the 4 different ways of inserting a new node in the double linked list. In that, the first one is inserting a new node at the beginning of the list. The insertion of a new node at the end of the list, then inserting a new node after the given element, and the other one is inserting a new node before the given element. Yes, these are the 4 different types of insertions we can perform in double linked list. Let us go ahead with the first one, inserting a new node at the beginning of the list. Yes. Let us consider this is a double linked list where we are going to have the forward direction and we can move backward also. In a double linked list, we are going to have a node starting represented with head and the last represents with the last node. Here we are going to represent the addresses of the nodes. In the single linked list, as we observed, we are going to have only the forward connection is present, but here we are going to have the backward connection also. Consider the 3 nodes here, what we have represented. Based on this, I want to insert a new node at the beginning of the list. That means here, before this, I need to add a new node. In that case, how we are going to write the operations? What is the first step is, we are going to allocate the memory by using malloc function, and the previous and the next address parts are initialized to null, and we are going to read the data value, and here I have read the data value as 5, and considering the name of the node is n and assume the address is 5000. This is how the node is created. Now we need to make the link between the new node which we have created and already existing head node, right? Let us see how we are going to make the connection. Now, I am going to store this 1000 into this location, right? Before going to store that into the null, if I am going to store the value here, instead of this, let us have this diagram once again. Yes, here we have created a new node, right? And making the connection between this already existing node followed by the new node which we have created. Now, storing the address of this one into this location, right? That means we are going to establish a link between this new node and the existing one. Now, what is the step we need to write? The name of this node is head. The name of this node is head. Head arrow previous. This location is called previous. Head arrow previous equal to the name of this one is n. So that we need to write this step. And then we are going to have a forward connection, and now we are going to store the address of 1000 in this location null. In that particular case, we are going to write this step as this name of this node is n, so that n arrow next, this location is representing next, n arrow next equal to this node name is head. That's why we are going to write n arrow next equal to head. After making these 2 connections, now this is the new node which we have inserted, right? Because of that, this becomes the first node and we need to name this node as the head node, right? That's why we are moving the head from here and we are making this as the head node. Head equal to n. This is the step where we need to mention, right? And let us see how we are going to write the subfunction for this. The first, these steps are representing allocating the memory dynamically by using malloc function, and reading the data part, we have read the value as 5, and the next value is initialized to null, and the previous value is also initialized to null, and the name of this node is n. So the steps where we are going to use for creating a node. Now we have seen the connections how we are going to make. The previous, head arrow previous, if you are going to consider, this is head arrow previous, where we are going to store the address as 5000. This is, if you are going to consider this as 5000, right? We are going to make the connection between the previous and the next one. N arrow next equal to head, this is the n value. N arrow next this location, we are going to store the address of this one, 1000, and at last we are going to make this as head instead of this one, right? This is how we are going to write the subfunction. Coming to the next insertion, inserting a new node at the end of the list. Already we are having 3 nodes in a double linked list. I need to add a new node at the end of the list, right? And you know that we are going to have the starting node will be represented with head, and the ending node is going to represent with last. Now the same procedure what we have followed for inserting a new node. Every time when we are going to insert means we need to allocate the memory. That means we are going to create a new node, right? Now it's the same process. We are going to allocate the memory dynamically, reading the data value, and address part of previous and next is assigned to null, and the name of this node is n. Now make the connections between these two. Yes, we are going to have the connection, the forward connection, and storing the address in this location. Now what is the step we need to write? N arrow previous. N arrow previous, in this place we are going to store the address of 3000, right? N arrow previous is equal to, the name of this node is last, that's why we are assigning to last. Next, making the connection, the backward connection, and here we are going to store the address of 4000. Now this is nothing but last arrow next equal to n, right? The name of this node is last, that's why last arrow next location we are going to store the address of n, that is nothing but 4000, last arrow next equal to n. Now after adding the new node at the end, this becomes the last node in the list. That's why we are going to move the last from here, and we are going to place this as the last node. This is how we are going to implement inserting a new node at the end of the list. Let us see the code here. Here these steps are common, where you are going to allocate the memory dynamically, reading the data part, next and the previous are assigned to null value. Next, we are going to make the connection last arrow next, whatever the node we have at the end, right? This is going to make the connection, and we are going to store the n value into this location. The address will be stored here, and n arrow previous, in this location we are going to store the address of the previous node and making the backward connection, right? And at the same time we are going to make, previously this is the last node, now this becomes the last node where we are going to represent. The next one, the next operation where we are going to perform on insertion is inserting a new node after the given element. Now you should be very careful when you are going to do this. Previously we have done this in the single linked list also, but there we have only one connection, the forward connection we have represented, but here we need to represent both the connections, forward as well as backward connection. That's why when you are making the connection, first do it on the right hand side. Remember this, first make the connection on right hand side. Why? Because we should not lose any memory address. Because of that, we need to make the connection on the right hand side, then followed by the left hand side connections. Okay, let us see in detail how we are going to make the connections, right? First thing, when you want to insert a new node after the given element, first we need to identify after which element we want to insert, right? Suppose consider I want to insert my new node after 20, right? My key element is 20, right? First I need to reach to that location, and after that I need to insert a new node after 20, okay? Now first, using my temporary variable, I need to search the element is there in the list or not. First I am going to assign my temp equal to head. Then it will be checking temp arrow data. If temp arrow data equal to 20, then I am going to stop there, right? Now it is here, the temp arrow data value is only 10. That's why we need to search in the next node whether 20 is present or not, right? Now I am moving my temp to the next location. Yes. Now it is going to check that yes, temp arrow data equal to 20. Yes, the condition is satisfied. Now I need to come out of my traversing path. Now create a new node by allocating the memory and read the data value, and next and previous values are assigned to null. This is my new node which I have created. Now make the connections. Before making the connections, make sure that what are the names of your nodes, right? If you are clear with the names of the nodes, then it is very easy for us to make the connections also, right? Let us see. Here, the name of this node is temp and the name of this node is n. And what is the name of this node? This node name is temp arrow next. This is temp, right? The name of this node is temp, and this is representing storing the address of 3000. That's why we can name this node as temp arrow next. This is the name where it is having. Okay. Now make the connections. This is the right connection where we are going to make. I have given you a note at the starting itself, where we need to make the right connections first, then followed by the left connections, right? Now, this is the first right connection where I have made, where I am going to store this address of 3000 in this location, right? What is the step we need to write? 3000 is storing into this location. What is this called? N arrow next. The location is first we need to identify. N arrow next. N arrow next equal to temp arrow next. This is the step where we need to represent next. At the same time, make another connection also, right? This address we need to store in this location, right? Now, what is the step we need to write? Observe carefully here. What is the name of this one? This name is temp arrow next. Arrow, this location is previous. Temp arrow next arrow previous equal to where we are going to store the address of 5000 is nothing but n, right? That one we need to store. Done. Next, the right part connections were completed. Next, coming to the next one, we need to make the left connections. Observe, I am storing this 2000 into this location. Now, what is the step we need to write? N arrow previous equal to temp. 2000 address name is temp. That's why we need to assign n arrow previous equal to temp. Next, the other connection also we need to make. That is nothing but here we need to store the address of this 5000. That is nothing but temp arrow next equal to n. These are the 4 steps where we need to represent. Okay, let us see the subfunction where how we are going to write for this. First steps are going to allocate the memory dynamically and reading the data part. Next and previous are assigned to null value. This is common when we are going to perform the insertion. Next, what we need to do? We need to read the key value until we are going to search the element is present in the list or not. If the element is present, then we are going to stop there, right? And after that, we are going to try to insert the element after the given element. Okay, that's why we are going to read the key value. Next, for moving in between the nodes, we are going to use a temporary pointer variable, that is temp equal to head. Now, by using temp, we are going to traverse through the list until temp is not equal to none. Now, we are going to search for the key element. That's why we are going to write temp arrow data equal to key. If you find the key value, then you are going to terminate the loop. If not, you are going to move temp to the next location. Temp we will be moving to the next locations for searching the key value, right? If the key value is not present until temp reaches the null value, it will be keep on moving or keep on traversing through the list, right? If it reaches null, then automatically your linked list traversing will be stopped, okay? If the key value is reached, then you will be coming out of the block or out of the loop, then you are going to make the connections. In this also, first we are going to make the right connections and then we are going to make the left connections. You can once check with the previous diagram which we have mentioned, okay, and based on that try to practice these connections properly so that we can implement the program very easily. This is about insertion after the given element. And the next one, insertion before the given element. And here also we are going to consider 4 nodes with the double linked list. The first node represents the head and last node represents the last. Now here before the given element, if I am going to choose a given element, before that I need to insert the new node. In that case, how we are going to perform this? Yes, let us see. First, when you want to traverse through the list, we are going to use the temporary variable. But with that, we are going to have one more pointer variable we are going to take. Why? Because we need to have the names for the nodes to make the connections. As we have discussed in the single linked list also, once you can refer that video for some more clarity why we are taking one more variable, okay. Just here we will see how we are going to assign a pointer variable to another new variable and how we are going to traverse through the list, okay. Let us see, I want to insert a new node before the key element 30, right. Now first I need to search for the key element. For that searching, first I am going to check a temp value. Temp will be assigned to head. Now temp will be moving through the list and then we are going to reach the key value, there we are going to stop, right. Now temp arrow data is 10. It is not equal to the key value, that's why I am going to move my temp to the next location. When I am moving my temp to the next location, in that case I am going to assign my temp to P1, right. That means what is the step we need to have? P1 equal to temp, right. Then we are going to move temp equal to temp arrow next. In the previous case we didn't do this, just we are assigning temp, we are moving the temp value and based on that we have traversed through the list. But here when we are moving temp to the next location, we are representing the previous node with some variable called P1 that is going to be stored, right. Next, again we are going to check this temp arrow data is 30, no, again. Now again I am moving my temp to the next location and this will be assigned to P1. Now you are going to check temp arrow data is 30, yes, it is 30, the search element is 30, now I am going to stop here. Now identify the names what was there for the nodes which we have. This is P1, this is temp and this is the name N. N is the pointer variable, right. Now make the connection between these nodes, right. First we always make the right connection. Store the address of 3000 here. Now write down the step N arrow next equal to temp. The name of this node is temp. That's why we need to write N arrow next equal to temp. Next one, we are going to make another connection where we are going to store 5000 here, right. Now what is that name called? Temp arrow previous equal to N. This is the step where you need to write. Now coming to the left hand side, here we are going to store 2000, means N arrow previous equal to P1 and this is the step where you need to represent. And the next one where we have P1 arrow next equal to N. This is the connection where you are going to make, where we are going to store the address of 5000 in this location. This is the step where we are going to write. And based on that, this is the sub function how we are going to write. This is where you are going to allocate the memory dynamically, reading the key value and temp equal to head, that will be moving in between the head and last, and until temp not equal to null we are going to traverse through the list. If temp equal to the key value, then we are going to coming out of the loop and make the connections. If not, then we are going to assign our temp to P1 and the temp will be moving to the next location. This is where we are going to have the insertion of new node before the given element. These are the 4 functions where we have. Let us see the summary what we have discussed under this session. Double linked list insertion we have seen. Under insertion we have discussed about the 4 concepts. One is inserting a new node at the beginning of the list, inserting a new node at the end of the list, and inserting a new node after the given element, and the last one is inserting a new node before the given element. Okay, this is how where we have discussed about all the double linked list insertion operations. In the next session we will be discussing about how to perform the implementation of this. Okay, thank you. If you have any doubts, please do comments in the comment section. Thank you.